is a practice question on free fall. To start out, we always write our three equations of kinematics. Those are the equations we use to solve for free fall problems. Free fall problems. So we have final velocity equals initial velocity plus acceleration times time. We have final velocity squared equals initial velocity squared plus 2 times acceleration times displacement. We have displacement equals initial velocity times time plus 1/2 acceleration times time squared. Okay, let's read the question. A student throws a coin vertically downward from the top of a building. So I'm gonna draw my picture. Helps me to visualize what's going on. I highly recommend you do this. There's my building, there's my person, and he throws the coin vertically downward at a speed of 13 meters per second. So our initial velocity of the coin is 13 meters per second. Now the coin is going down, so that means this is negative, because usually negative is the down direction, positive is the up direction from where we start. How far does it fall? So D equals question mark in a time of 1.80 seconds. Now we know our acceleration. If it's a free fall problem, we always know acceleration. Acceleration is always a negative 9.81 meters per second squared. Now it is a negative because acceleration or gravity always goes down. So now we match up these variables with one of these equations over here. So VF, no, I don't have that over here. VF, no, I don't have that over here. D, I have that. VI, I have that. T, I have that. A, I have that. And T, I still have that. So this is the equation that we're going to use. So we say D equals VIT plus 1/2 AT squared. Okay, so we just plug our numbers in. D equals, VI is negative 13. The time is 1.8 plus 1/2. Acceleration is negative 9.81. And T, I'm running out of room here, becomes 1.80, and that is squared. So now we're going to do some math. Sorry, I got a little crowded right here. So get my calculator out, and we're going to do 1.8, square it, times it by itself. So 1.8 times 1.8 equals times 9.81 equals times 0.5 equals, it gives me 15.89. Now, this is all negative because we have a negative here, so it becomes a negative. Do a little math here. We get 13 times 1.8 equals, I get 23.4. And that is also a negative. So my displacement then becomes 23.4 negative minus a 15.89 gives me a negative 39.3, and that would be meters. And that is our answer. Now, these are multiple choice questions, so you want to look for the answer that's as close to this as possible. But you also want to take in consideration, is it a vector or not? Now this says how far does it fall. It's hard to tell if they're asking for a vector answer, which is a negative 39.3. It's negative because it's going down. Or if they want a distance, which is not a vector. If they want a distance, the answer will just be 39.3. Because there's no direction on a distance. So this would be the distance, and this would be the displacement. Okay? So that's the displacement. That's the distance. And you don't really know what they're asking for because the question is a little confusing until you look at the answers. So it'll either be a negative 39.3 or a 39.3, depending if they want displacement or distance.